The objective of this lesson is to introduce you to the row to column data transposition with the pivot function in Oracle. The task is to transpose the employees table and return the total number of employees who were employed in each department for each year. In this case, let the column names be the year of hire and the rows be the department IDs. In Oracle 11G, Oracle introduced a pivot operator that performs a row to column transposition. Using the employees table in the HR schema, we will test the functionality of this pivot operator as well as answer this challenge. Each row on the employees table represents information about a specific employee, including the employee ID, the last name, hire date, department ID, and many other attributes. We can see that it is row-based data. With the pivot operator, we can transpose or cross-tabulate the employees table such that the years of hire appear as column headings and the count of the number of employees who were employed during each year is performed within each department. Let's turn over to SQL Developer and see this in action. Over here in SQL Developer, we can see that the employees data is represented as row-based data. There's nothing new in the first statement. In fact, it simply selects fields that are stored within the employees table. But in the second statement, we perform a pivot of the row-based data. First, we have a subquery in which we query the columns of interest from the employees table. That is, the columns that we would like to include in our cross-tabulation. Notice that I have used the extract function here to extract all years from the hire date field. Then, we use the pivot operator to generate a cross-tabulation. In fact, it is probably easier to read this pivot section backwards. Here in the in clause, we specify the values we want to pivot. That is, the values we want to appear as our column headings. The field passed into the for part of this clause is the column we are actually testing against. So the values passed in the in part are entries found in the column specified under the for command, and in this case, the year of hire. And finally, there's an aggregate function which defines how we derive the values of the pivoted column. In this case, the count of employees ID is what we're using to derive the values for each of these columns. Note that you could use any aggregate function here such as sum, max, min, average, or whatever function you desire. Let's run this and see the results. From the output, we can see that our initial row-based data is now represented as columns in a single row, showing the number of employees employed during each year. But this does not break down these values to different departments, which is what this challenge is all about. Having these counts, but also breaking them down to different departments. To break this down into different departments, we simply include the department ID in our initial select statement, in this case, our subquery. And if I run that, then it gives me exactly the same results as the previous query, except that it breaks down the count values by department. So a department with ID 10 had 0 hires in 2001, 0 in 2002, 1 in 2003, and so forth. Again, we can see the power of a subquery that we touched in a previous lesson applied to this pivot functionality. Whatever fields we want to appear here in our pivot results would have to be passed into the initial select statement. In this case, adding the department ID made it possible for us to break the results down to department level. So that is the pivot function which was introduced in Oracle 11G and comes very handy when you are doing cross-tabulation within Oracle.